So the next chapter we're going to start is chapter 5, and so we'll start off with section 5.1. Now, before we get into it, this whole chapter is really dealing with what's called analytic trig, and so we're going to be talking a lot about something called trig identities. So this is going to be a huge portion of this chapter. And actually, the goal in this one is really just to rewrite trig expressions using trig identities. So what the heck is an identity? To start off with, we'll just kind of talk about what a trig identity is, and then we'll actually do some examples in a later video. So I want you to think about identities as essentially formulas. They're a little bit different because these formulas are actually true for all values of the variable. Whereas a formula is really just looking at a specific number that's being inputted. So for example, if I said, a formula might be the gas law PV equals nRT. And so this is telling me I could plug something in for T and I could get something out for P. So formulas are more about plugging in and getting an answer. Whereas an identity is going to be true for all values. So for example, this is going to be a really stupid one, but let's just say I said x plus 1 equals, let's say x plus 2 minus 1. Now notice on the right hand side there, that's really just x plus 1. But the point is that if you look at this expression, this is true, or sorry, this equation, this is true for any x value. So this might be considered an identity. We wouldn't call this an identity. We'll see some trig identities in a moment, but this is true for any x value. So this isn't really a formula, but this is kind of what we're going to be talking about with trig. All right, so now let's go ahead and write down some trig identities. Once again, you can think of these as formula. These are given to you. You can use them on tests and quizzes and stuff, quests. But we're just going to look at a couple of different trig identities. So the first ones are ones you've actually seen before. I often don't even write these on formula sheets. They're called the reciprocal identities. And so if I said cosecant of x or theta, that's 1 over sine of theta. Secant of theta is 1 over cosine of theta, and then cotangent of theta is 1 over tangent. So those are the reciprocal identities. You can also sort of flip this around. You could have sine of theta is actually 1 over cosecant. These are ones I kind of just expect you to memorize. Like I said, I don't usually put these on formula sheets. So hopefully you've gotten pretty good with these ones. But those are considered the reciprocal identities. Notice no matter what I plug in for theta, this equation will be true. That's why this is called an identity instead of a formula. So it's true for any theta. The next one is also going to be one that's pretty familiar, the quotient identities. So we have quotient, we have reciprocal. These ones have to do with tangent and cotangent. So tangent is sine of theta over cosine of theta. And cotangent is, so remember cotangent's the reciprocal of tangent, so therefore cotangent is cosine over sine of theta. And those are the quotient identities. So all of these, like I said, I won't really be putting on a formula sheet. You should have these essentially memorized. Okay, the last one is one that you have been introduced to, but we're going to do a little bit more with it. It's called the Pythagorean identity. And this has three forms essentially. So the first one is sine squared of theta plus cosine squared of theta equals 1. This is my all-time favorite identity. I think it's super cool that if you square both of them and add them up, you get 1. And it comes from the unit circle. So if you're on a unit circle, the radius is 1. Then if you did x squared plus y squared, you would get 1 from the Pythagorean theorem. That's a right triangle right there. And then x is just cosine and y is just sine. So replacing x and y, you end up with the coolest Pythagorean identity, trig identity. Now there's two other versions of this. Essentially what we do, I'll kind of show you the work over here. Not that you have to know this, but it does help, I think, to know where stuff comes from. So in the first one, we're going to divide both sides by sine squared of theta. And so what ends up happening is I have 1 plus cosine squared theta over sine squared theta, which equals 1 over sine squared theta, which is really just 1 plus cotangent squared of theta equals cosecant squared of theta. And then for the other version, the other alternate version, we're going to divide the original by cosine squared this time. So I end up with sine squared theta over cosine squared theta plus 1, and then that equals 1 over cosine squared. And so that ends up giving me tangent squared of theta plus 1 equals secant squared of theta. Okay. So all three of these are considered the Pythagorean identity. We just have sort of three different versions, but they're all essentially the same thing. All right. Now there's a whole lot more, and I'm going to show you just in a moment here a list of them. We're not going to get into all of them today. We'll just be using these ones for the section 5.1 content. But if you want to take a look at what's coming, if you look under the classwork over here and you click on trig identities, you'll see a whole list. We have Pythagorean, cofunction, double angle, sum and difference. These last sequence ones are not for identities. Those will come up later. But then here's some more half angle and power reducing. So this is a complete list of identities you might come across at some point. You can also just Google trig identities and you'll come up with lots of different lists. There's pictures, there's images, there's web pages, there's all sorts of stuff on this. It's a really common topic. Okay, so we now have our identities. Let's just write those down as kind of a summary. We have reciprocal, typo. We have reciprocal identities. We have quotient. And then we have the Pythagorean. And so these are the ones that we'll be using in the next video. So make sure you have these easily referable so that you can kind of flip back and forth as we're doing problems.